All right, welcome. Today, we're going to pull back the curtain on a piece of invisible tech that you probably use dozens of times a day without even realizing it. So let's just jump right in with a question I bet you've thought about before. Seriously, think about it. You walk into a public restroom, you wave your hands under the faucet, and boom, water starts flowing. How in the world does it do that? Is it a tiny camera, some kind of motion detector? What's the secret? Well, the answer isn't actually magic, but honestly, it feels pretty darn close. It's all thanks to this super clever and incredibly common piece of technology called the infrared sensor, or just IR sensor for short. So, what is this thing really? Well, the official definition is that it's an electronic device that uses infrared light to do its job. Whether that's spotting an object, figuring out how far away it is, or detecting motion. The key phrase here, the most important part, is invisible light. See, infrared is on the electromagnetic spectrum just like the light we see, but its wavelength is just a little too long for our eyes to pick up, and that's exactly why it can be working all around us and we're completely clueless. So, how does this invisible system actually work? It's surprisingly simple, and it all comes down to two key parts that work together like a perfect team. On one side of the team, you have the IR LED. That's the transmitter. You can think of it as the one who's constantly shouting out into the dark, sending out this beam of invisible light. And then on the other side, you've got the photodiode. That's the receiver. Its entire job is just to listen, to wait and see if that light ever bounces off of something and comes back. It's kind of like a little game of high-tech Marco Polo. This whole process is what I like to call the send and receive dance. It's a really straightforward four-step routine that is at the absolute heart of how every single one of these sensors operates. Let's break it down. It's easy. Step 1. The LED sends out its invisible infrared rays. Step 2, if something gets in the way, let's say your hand, those rays hit it and reflect. They bounce right back. Step 3, the photodiode sitting right next to the LED sees those reflected rays. And finally, step 4, as soon as it sees that light, the sensor creates an output signal. Now, that signal isn't anything complicated. It's basically a simple yes or no. If the photodiode catches that reflected light, it sends out a high signal, a 1, which just means, hey, something's here. But if it doesn't see any light coming back, the signal just stays low, a 0, meaning, nope, nothing to see. It's this simple on-off switch that makes all the cool stuff happen. Okay, so we've got the theory down. It's a simple little dance of light. But where does this thing actually show up in our day-to-day lives? The answer is, well, pretty much everywhere. Let's take a look. So just to recap, these sensors are great at a few key things. They can tell if an object is present, they can measure short distances, they can sense motion, and they can even help little robots tell the difference between a black line and a white floor. Now, let's see that in action. You walk up to a grocery store and whoosh, the doors slide open for you. That's an IR sensor. It detected your presence and sent that high signal, that 1, to the door's motor to get it moving. And there it is, the answer to our big mystery from the beginning. That touchless faucet has an IR sensor. It sends out its light, your hands reflect it back, and the sensor tells the water valve to open up. Simple, hygienic, and yep, no magic needed. Oh, this one is an absolute classic. Every single time you press a button on your TV remote, an IR LED at the tip sends out a little coded message in invisible light. Then, the IR receiver on your TV reads that message and bam, the channel changes. Now let's get a little nerdier, because in the world of robotics, these things are everywhere. A line-following robot, for instance, uses IR sensors pointed at the ground. A black line absorbs the light, which gives a low signal, while a white surface reflects it, giving a high signal. That's literally how it knows to stay on the path. And in that same vein, a lot of small robots use IR sensors as their eyes to keep from bumping into walls and furniture. If the sensor gets a reflection back, it knows there's an obstacle and it needs to stop or turn. It's just a fundamental tool for basic robot navigation. So after seeing all these examples, from your bathroom sink to little robots, what's the one big idea you should walk away with? I think this quote just nails it perfectly. An IR sensor detects objects using invisible infrared light. It sends IR rays from the LED, and when these rays reflect back from an object, the photodiode detects it and gives output. That is the whole shebang, right there in one sentence. And really, it is that simple. It's this reliable little process of sending and receiving a beam of invisible light that powers so much of the convenience and, the magic that we just take for granted every single day. So the next time you see an automatic light flick on or watch a robot vacuum cleaner do its thing, you'll know the secret. You'll know what's happening. My question for you is, now that you can see the invisible, where else are you going to spot it? Thanks for watching.